This physics question deals with calculating energy of a system, specifically particle energy and kinetic energy, and how the two are related. An electron with a speed of 0.95 c is emitted by a supernova, where c is the speed of light. For part A, what is the total particle energy of the electron? We know that total energy is equal to gamma times mass times speed of light squared. Gamma is given as 1 over square root of 1 minus velocity over speed of light squared. Both of these equations, gamma and total energy, are found in your equations page attached to your test. From here, we plug in 0.95 c for v in the equation. Since c is in the velocity, we can cancel out the c's and square the term. This will give us 3.203 as gamma. Now that we know gamma, we can solve for total energy. We plug in gamma as 3.203. For mass, we use 9 times 10 to the negative 31st, which is given in your formula packet, and 3 times e to the 8th squared for c squared, which is also found in the packet. From here, we get that total energy is equal to 2.59 times 10 to the negative 13 joules. For part B, what is the kinetic energy of the electron? To solve for this, we know that kinetic energy is equal to gamma times mass times speed of light squared minus the rest energy, which is mass times speed of light squared. Since we already know what gamma is, and all the other information, we simply plug and chug for this question. When we calculate this using proper parentheses in our calculator, we end up with the kinetic energy as equal to 1.784 times 10 to the negative 13th joules. For part C, a force of 2 times 10 to the negative 8, negative 4 times 10 to the negative 8th, and 3 times 10 to the negative 8th newtons acts on the electron as it moves over a displacement of negative 0.03, 0.05, and 0.07 meters. What is the work done on the electron by this force? First, we must establish what the equation is to find work. Work is equal to the force times the displacement. Given that our force and our displacement are both in vectors, we must use the dot product to find the work. The dot product multiplies the x terms together and adds them to the y terms multiplied to each other, which is added to the z terms multiplied to each other. We then add all these up together and find that work is equal to negative 5.0 times 10 to the negative 10th joules. For part D, determine the new kinetic energy. First, we know that change in energy is equal to work. Change in energy can be broken down into rest energy and kinetic energy. Given that at rest, velocity is equal to 0, we can just set change in kinetic energy equal to the work. This breaks down into the final kinetic energy minus the initial kinetic energy. Substituting information we found in part C and part B, we find that negative 5 times e to the negative 10th plus 1.784 e to the negative 13th is equal to this number. This can be further simplified into the final kinetic energy, or the new kinetic energy, is equal to negative 5.0 times 10 to the negative 10 joules.